Well, hello there. I'm Mr. Walters, and I'm here to teach you how to rap, but not with words, with chemicals. So, what we have on the board here is a chemical equation. You might see it very soon on one of your tests. And so for you guys who are in Mr. Singh's class, I'm doing this video so you guys can learn how to do this method. There are other methods out in the world that are probably better than what I'm teaching right now, but if this one works for you, go with it. The first thing we start out with is R. And R stands for, everybody?
Reactants.
Reactants. This side of our equation is our reactant side. It's the things that react. Over here we have our products. They're the things that we make. And it makes sense because if you think about it like in a store, they buy stuff and create products and sell stuff. So like this is the stuff we're buying, that's what we're selling. Then we're going to do this table here. We call it a RAP table because we're using these letters. The R comes from reactants, the P comes from products. Mr. Walters, where does the A come from? The A stands for atoms. Great job, Gabby. But the A stands for atoms. So what we're going to do when we have our RAP table, guys, Junior, pay attention. What we're going to do is we're going to look at our coefficients. Now, you guys had me for algebra and you probably forgot, but coefficients are numbers in front of the letters, numbers in front of the letters. Here, same idea. So over here, I'm going to list out all of my atoms. Class, what does this H stand for?
Hydrogen.
So in the middle where it says atoms, we're going to say hydrogen. What do we have here? Sulfur. What do we have here? Oxygen. What do we got here? Lithium. Good job. And what do we have here? Oxygen. Already got it. What do we have here? Hydrogen. Now, you will see, guys, that there is a polyatomic ion. You might not remember what that is, but you'll learn about it soon. You could treat the polyatomic ions as a single unit, or you can divide them out. I find dividing them out helps these guys understand better. So that's what I did. Now we're going to count how many of each of these atoms we have. We're going to first start on the reactant side. If I look at this hydrogen, there is a subscript of 2. There is actually a 1 in front, and when we are doing coefficients, we are actually multiplying. So 1 times 2 is? 2. But I got this one over here as well, right? So how many hydrogens do you see on the reactant side? 3. Then we're going to look at our next one. This is sulfur. I got 1 sulfur here, and that's it. So here I'm going to put in uno. Yes, guys?
Yeah, there's a 2 in front of the LIOH, so to multiply that.
I'm talking about the S.
No, for the other one.
Oh, my fault. Class. Sometimes I make mistakes because, it's Mr. Walters. This is something that is a good thing that the class brought up for me, and I did it on purpose. If there's a coefficient in front, we actually have to multiply that to everything that's below it. Now, the subscripts here are 1 and 1. So 2 times H is actually 2. So instead of saying 3 hydrogens, I actually have 2 here and actually 2 over here. Let me repeat that for you guys one more time. If you have a coefficient, we are multiplying them. And so that's why there are 2 hydrogens here, and this 2 multiplies to this hydrogen, and we get 2 more. So that equals 4. I think I'm good now, right, class? Yes. Okay, sulfur is only 1, right? Let's count our oxygens now. Our oxygens, we have 4 here, and how many here?
2.
Good job, Sam. Way to pay attention. We have 2. And 4 plus 2 is, everybody? 6. Lithium. I got how many lithiums right here? 2 of them. Why 2? Because there's 2 times how many are there? So we have 2 lithiums. All of my reactants are labeled now correctly because my class helped me out. I'll make this 4 look better. And now we're going to look at our product side. And our product side, I will have to add some coefficients. So we're going to look at our subscripts. How many hydrogens? 2 of them. How many sulfurs? 1. How many oxygens? 4 plus? 4 plus?
1.
1, which is what? 5. And then finally our lithiums. 2. Now, if we look at this table, we know for sure that we are not balanced. The reason we're not balanced is because we have different numbers on this side to this side. We will know we are balanced when these numbers match these numbers. The book kind of tells you that you would like to usually look at the biggest number you have first here. So if I was looking, I'd probably try to balance the oxygen. But we'll see what the class wants to do. I'm leaning towards they want to balance the hydrogen. So we'll start with the hydrogen in this situation. How can I make a 2 become a 4? I'm going to multiply it by 2. And when I multiply by 2, I'm going to add a coefficient up here. Do you see this coefficient right here, class?
Yes.
Good job, Leanne. So, in this group here, we have to recount. Every single time I do something, I tell my class to go back and recount all your islands. I did not do anything to the reactant side, so I'm not going to count that side. But I did do something to the product side, and if I recount, instead of having 2 hydrogens, 2 times 2? 4. If I go through and count everything else, the only thing I'll change is my oxygens as well. So here, instead of saying 5, I now have 4 here, and 2 times 1 is 2, which equals 6. If you guys notice, that works out here for me, because now this matches, and this matches, and this matches, and this matches, and we are all balanced. So the coefficient that goes here is just a 1. And that's all we do.